We're live. Hi guys, welcome back to our next session. So our session now is on Java basics. You guys have been doing a bit of Python programming in the past, and now we have Java, which is a really awesome programming language as well. Welcome from the App Inventor class. I hope you guys had fun over there. But here you're going to have even more fun. Please stick around till the end of today's sessions because today is prize giving day, and I'm sure you want to win awesome prizes. I'd like to hand over to our Java instructor, Haskak Pioneers. Is that correct?
Yes, that's correct.
Oh, okay. His name is Wilbert. Okay. There are multiple people. Sorry. Okay, so you guys can take over. Bye, guys.
Okay. Aiden, would you like to share your screen?
Yeah, I got it. I can't tell if that.
Hi guys, you're live.
All right. Do you know if that's working for the screen share? No clue how this works.
I'm having on the live stream now. Should be working, I think.
All right. You want to start off then?
Yes. All right. So, my name is Wilbert Joseph, and I'm here with Aiden McNamara. And today we're going to present to you the basics of Java in simple terms. And using simple English, our goal is to explain to you the very fundamentals of Java programming, as well as programming concepts in general. Now, if you have any questions, feel free to leave them in the chat, and we'll try to answer them as soon as we can. And yeah, thank you for being here.
All right, so basic overview of what we're going to go over today. We're going to talk about Java and what its uses are, and then move into the different types of variables in Java, talk about different types of Boolean operators, true or false statements, conditional statements like if and else statements, loops like for and whiles, arrays, 2D arrays, and move into classes and making instance variables, constructors, and methods for those classes. So a basic overview about Java is that Java's everywhere, even if you don't really know it. Many major websites and apps use it, like Spotify and Twitter, some other websites like LinkedIn and Amazon that you use all the time. Some big things like the NASA Whirlwind web application, and like video games that you might even play like Minecraft. It all comes from Java. And the same code will run everywhere, like on any machine or anything.
All right, so the first thing we would like to teach you about Java are data types. Data types in Java are split into two main categories. There are primitive types and objects. Primitive types are the most basic types in Java. They come with a predefined set of operations like addition for integers, multiplication, subtraction, things like that, and they're defined into Java type system by default. Next are objects. And objects are defined by the coder through a class. Its attributes and functionality are totally up to the will of the programmer and often utilize primitive types to store data. And over here on the right, we have an image which depicts a couple of primitive types. We have doubles and integers, which I'll get into in the next slide, and a couple of object types, which include classes and interfaces. Interfaces we won't cover in this presentation, but we will cover classes and the basics of the structure of classes. Next slide, please. So on this slide, we have a couple of common and basic data types. We have integers. There are 4 different types of integers in Java. There's a byte, a short, an int, and a long. And the main difference between the 4 of these is the range of numbers that each of these types can store. And the reason why each of these types store a number in a different range is basically to save memory in the computer, because sometimes you know that you're going to use a number that doesn't require that much memory because it's not that large, so you can use one type as opposed to another type. Next, we have floating point numbers, which are basically decimals. Float can hold 6 to 7 decimal digits, while a double can hold up to 15 decimal digits. Next, we have characters, and in Java, a char is a character, and basically it's an individual letter. Some examples are listed there. We have A, B, and M, and they're denoted by a single quote. Next, we have strings, and a string is basically a list of characters all connected into one variable. So we have examples there like words, hello, and or, and you can see that they're basically a bunch of individual characters put into one single variable. And lastly, we have Booleans, and a Boolean basically contains either a true or false value. So yeah, it's simple enough. And if we go to the next slide, we'll see how each of these are implemented in Java. So up top here, we have string name equals Scotch. So on the left side, we have the type of variable and its name. The type would be string, its name would be name, and on the right side, we have whatever we want the value of that object to be. So in this case, the string variable is named Scotch. Below that, we have a Boolean. It's set to true. Its name is tired. We have an integer. Its name is age, and it's set to 1. And what you might notice is that all of these describe the puppy here we have on the right. And we'll be using this example throughout the presentation to make things cohesive. Once again, if you have any questions, just drop that in the chat and let us know. I see one question here. Is Java and JavaScript the same thing? No, Java and JavaScript are not the same thing. Java has a couple of different uses. JavaScript is used in web development a lot, and there are slight differences. They are not the same languages. Okay, next slide. So here we have a couple of Boolean operators. And if you remember, Booleans are primitive types that contain either a true or false value. And in general, Boolean operators are used to control expressions and decisions of loops and conditional statements, which Aiden will explain in a later slide. So the first of the Boolean operators are the AND and the OR operators. The AND Boolean operator, which is represented by 2 ampersands, evaluates to true if 2 Boolean values are both true and false otherwise. The OR operator, on the other hand, which is represented by 2 straight solid dashed lines, evaluates the true if either or both of the Boolean values that you're comparing are true and false otherwise. Next, we have the NOT operator. The NOT operator in Java can be used to invert or turn from true to false or false to true, and it's represented through an exclamation point in Java. Next, we have...
Oh, wait, no, that didn't... Up there. Do you want to move?
No, go back to the last slide.
Okay.
Next, we have the basic Java comparison operators. And these include greater than, less than, greater than or equal to, less than or equal to. And these are the basic comparison operators. You've probably seen them in your math class before. And yeah. And in the next slide, we have a couple of examples of each of these in implemented in Java. So if we use the same variables that we declared before, we can use each of those 3 variables to utilize these Boolean operators. So we can check if is tired and is hungry is true. As we see here on the left, is tired is set to true and is hungry is set to false. So if we were to compare them with the AND statement, which checks if both of them are true, the result would be false because one of them is true and one of them is false. And because both of them are not true, the result is false. Next, we have is tired and is cute. And as you can see here on the left, both of them are set to true, so the final result is true. Now, if we were to use the OR statement, as long as one of the 2 variables are true, the final result will be true. And this is shown through is tired and is hungry, even though is hungry is false. Because is tired is true, the final result is true. Is tired and is cute, both of them are true. So when you compare them with the or statement, the answer is true. And down here at the bottom, we have age being compared to weight. They're both numbers, so you can compare them in Java. And they're being compared using the double equal sign, which is a comparison operator and checks if these two variables are true. And because these variables are not equivalent, the result would be false. Now, if we compare them using the not equal sign, which I don't know if you remember, uses an exclamation point, you would get that the result is true because age is in fact not equal to weight. Age is equal to 1 and weight is equal to 30.5. And next we'll have Aiden going into conditional statements.
All right. Conditional statements are statements that perform different actions depending on a specific Boolean value that are the things that we just went over. The if statements are used to if you want to do something in a certain case. So if the given condition is true, then it will do the thing. But if it's false, it'll just go over the statement. An else statement is put after an if statement. And if it's put after that, if the statement is false, it'll do the else statement instead of doing what's in the if statement if it was true. The else if statement is to add other conditions. So like if this one condition doesn't work, you can move on to another condition and then another, and then you could have an else to cover all the other conditions. All right. All right, so here, if the Boolean is hungry, which is false, says eat, well, it's false, so it wouldn't eat. And if it says if tired, else if, so it would go down there. And that's true, so it says it would sleep, and then the method would, and then the code would be done with the if statement. So then for loops, there's a while loop, which will perform an action over and over again until a condition that is given is met, which is another one of those Boolean operators. There's things called infinite while loops, where if the condition will never become false, it just goes on forever and is an error in your code. The do while loop is a variation of a while loop, which is basically it'll do the iteration, or it'll do what the code says first, and then continue as a normal while loop with the given condition after that. On the other hand, another type of loop is a for loop, which is given to perform an action like a certain number of times. So what you're going to do is you're going to give it a variable, and then give it an ending condition, and then give it what will happen after each time you go through the code. And then it'll end as soon as the variable reaches that ending condition. So an example of this, well, how you'd want to use them in different cases is to do it a certain number of times, you're going to want to use a for loop. And if you just want to repeat something until something happens, you're going to want to use a while loop. So a solid example here is for the for loop. It's going to go through the for loop code like 10 times as the numbers indicate it'll end. And then it'll go through eat 10 times and the while loop until, well, this is an example of an infinite while loop because the condition will never change unless the sleep method changes the variable. And yeah, the do while loop will do eat a snack once and then keep going while is hungry is true, but it's false, so it should go over it. All right. Now on to Wilbert with arrays.
Okay, so there are 3 different types of arrays in Java, and what an array is, an array can be described with a 1D array. So an array in Java is a collection of memory locations sharing the same data type. Individual elements are denoted by an index, and elements can be called upon and or changed. So in the diagram on the right, we'll see that there's a 1D array depicted there. And in this case, it's a 1D array of characters. Each character in the word coding geek is depicted by a number below it, and that would be its index. So if I wanted to call upon the 5th element in this array, I would go to the 4th index because, as you can see, the indices start with the number 0. So if I wanted to go to the 5th index, I would count 0, 1, 2, 3, 4, and I would actually get to the 4th index, and I would get the letter N, and I could access this variable. I could just use it elsewhere if I wanted to use the letter N, or I could change this variable. I could change it to the letter T, the letter S, to the number 5. Whatever I wanted to do, I could change it, or I could access it. However, the restriction when it comes to 1D or 2D arrays is that you cannot change the size of the array. So you cannot add an element to the end of it. You cannot take out an element in the middle of it. You can only access or change variables. Next, we have 2D arrays. 2D array is also a collection of memory locations sharing the same data type, but instead of being organized as a row of indices, it's organized as a matrix of rows and columns, and individual elements are denoted by a row and column R and C. You can see here on the right, there is a 2D array on the right, and each element is denoted with an individual row and an individual column, and you can call upon individual elements of this 2D array by calling by its specific row and column. So the way I like to think about 1 and 2D arrays are students in a classroom. If you have a row of students, you can label each student with a number, and in a sense, that group right there could be considered an array because each student is assigned to a number, and you can call upon an individual student just by calling upon a number. For 2D arrays, you can think of an entire classroom of students. You can think of rows and columns as students. So instead of just calling a specific student by its number, you can call the student by his or her row or number, row and column. So that's how you can remember 1 and 2D arrays. Lastly, here we have array lists. An array list is also a collection of memory locations sharing the same data type, but the difference is that the size of the list can be changed. So, like I said before, for 1D arrays and 2D arrays, you cannot change the size of the array. You cannot add elements to the end. You can't add elements to the middle. You can't take away elements. But for array lists, you can. You can remove elements where you want. You could add elements where you want. So they're a lot more versatile. The drawback of array lists is that when using array lists, you have to keep in mind that they take up more space because they allow you to add and remove elements at will. They require more computational power, and sometimes they can take more space because it takes more time for the computer to add and remove elements. It's a more difficult task. Yeah. Next slide, please. So next we'll be going into classes. And classes are really the backbone of Java programming because classes outline the blueprint for creating objects. And objects in Java are they're entities that have both states and behaviors. Classes are split up into 3 main sections. There are instance variables, constructors, and methods. Instance variables hold values that are referenced by other objects. They're basically the characteristics of that object that you want to create. Constructors are used to actually create the objects in memory, and methods are used as a collection of statements grouped together to perform an action or operation. So they essentially hold a function, and they produce a specific desired result. An example here at the bottom would be describing a dog using a class in Java. So if we wanted to describe a dog, the class name would be dog. The instance variables, which basically describe the dog by its attributes, would be its color, its breed, its age, really anything that you could think of that could describe this animal. In this case, the color would be black, and the color is denoted with double quotes, which one of you mentioned in the chat. Strings are denoted through double quotes, and that's how we know that what we're looking at is a string. The breed could be lab. In this case, it's a Labrador. And lastly, we have its age, which is just represented through a single integer, 1. And at the bottom there, we have methods. And methods include, if in this example, methods would include increment age and get age. Increment age could add 1 to our age if we wanted to, in case our dog got older. Get age would just return the dog's age. And something you might notice here is that methods can both access variables or they can change variables. Increment age would change our instance variable age, however much we wanted to increment it. Get age, on the other hand, would just return the value that age currently is. Next slide, please. So here we have instance variables. And like I said before, instance variables are characteristics of an object and a class. They hold values that are referenced by methods and sometimes other classes. And as an example, there are many attributes an object can have. For example, a dog can be described by its name, its age, its weight, etc. And each of these attributes can be stored in instance variables. So here on the right, we have an example of instance variables being created. We have all of the variables that we listed before. We have the dog's name, we have whether or not it's tired, we have its age, whether or not it's hungry, its weight, and whether or not it's cute. And something you might notice here is that preceding each of these variables is the word public or private. And it may look a little scary, may look a little complicated, but it's actually pretty simple. Basically, these words public or private denote whether or not other users coding in whatever object and whatever class you created, whether or not they can access these variables. So if this variable here is public, then other people can access it. If it's private, other people can't access it. That would be the most simple way to describe public and private, in my opinion. Next slide, please.
Yep.
Next, we have constructors. And constructors are a unique method in Java. And methods, Aiden will get into in his next slide. But constructors specifically are called upon to initialize or create an object. They can be made to accept information or not. And usually they initialize, which means give value to. And they give value to the instance variables of the class and call any necessary methods to build the object. So on the right here, we have an example of constructors being used. So this would be a full class example. Our class is called dog. And at the top, we have our instance variable, private int age. So it's an integer holding some value, and the integer is called age. And below that, in bold, we have our constructor. It's named public dog, and dog, the name of the constructor, also is the name of the class. And that's true in any class in Java. The constructor will always be the same as the name of the class. And inside the parentheses next to dog, we have what's called a parameter. And a parameter is what other people using your class will put information into. So in this case, what's going into the parameter is an integer called dog age. And in this case, our private instance variable age is being set to the parameter dog age, which was set outside. And that can be shown through our main method here at the bottom, which creates a new dog object using the class dog that we created up here at the top. So dog, my dog equals new dog 2. The 2 is actually the int dog age, and that's being set equal to age, which is an instance variable of the class. That might have been a little complicated. Feel free to ask questions and get anything cleared up if you would like. But for now, we'll go on to the next slide, which is methods, which Aiden will cover.
All right. Methods define some of the actions that the object you just made could make. So they return information or like change the state of the instance variables. The method headers, which is the public int and then the name of the, or public void, or that defines the return type of or title of the method. So it would be public and then the return type and then the title. The return type could be any type of data type that we discussed at the beginning, or it could be void. So if it is the data type, the method must end by returning that variable back to the where the method was called, or it could be void, which means you're just like changing something and it doesn't need to have a return value. A common use of these methods would be getters and setters, because a getter would get the value of an instance variable and bring it back to where you need to use it, and a setter changes the value of an instance variable so that it could be, changed and used again. If you see on the side the example, there's public int get age, and that's just returning the instance variable of age. And then there's a setter below that, which would take a new age and set age to that new age. Now, parameters are, as Wilbert went over, variables that are taken in the parentheses as user input and used in the method. So used in the setter that's in the example, there's one parameter. So when that method is called, there would be a new age input, and that would set age to that new variable number. All right. So this brings us towards the end of our presentation. So we'd like to recommend a few of our websites that we think would be really good for helping to learn Java. There's CodingBat, SolaLearn, Code Academy, and Udemy. These are all really useful, have good examples, good practice, and there's really so much, and programming is only going to become more important as time goes on. So feel free to take advantage of these links.
Mm-hmm. And I see a question in the chat, which is a great question. Right. How do you get to program in Java? I know it's a programming language, but how do you get it? That's a great question. In order to learn programming, the best thing you could do is learn on your own and program on your own. So what you'll need to program in Java is an integrated development environment, also known as an IDE. And there are a couple of different IDEs in Java that use Java. But the one that I used and the one that Aiden used, and that was pretty intuitive and helpful, and it's really good, it's called Eclipse. So you can use Eclipse to code in Java. I'm pretty sure it's free, and you can install it online, and you will be able to practice. You'll be able to run through code if you'd like. And yeah. If there are any other questions, you want to go to the next slide? Yeah. If there are any other questions, you can drop them in the chat now, or if questions come up later, feel free to email either myself, Aiden, or our head coach, Mr. Theodore. And you can also contact us on our page at team1676.com. So I think we'll just wait a minute, see if there are any other questions in the chat.
Yep, I will. Stop the screen sharing. Or should I keep the presentation up in case there are questions?
Yeah, just keep it up.
All right.
yes, as our coach mentioned, the presentation will be available through the publications link. So if you guys want to go over any of this information on your own, feel free to. We've made this accessible for all of you. And once again, if you have any questions, feel free to leave them in the chat or email us individually. We'd be happy to help you guys learn. All right, so it looks like there aren't any questions.
All right.
But one thing that's robotics specific, that's interesting, is the fact that Java is used in FTC programming. You can also use it in FRC programming. You can use it in either of those if you'd like to. So really, Java is used everywhere, even in robotics. It's really a versatile language. It's really powerful. And there are libraries made specifically for FIRST that you can use to program in each of these competitions. Just an interesting side note. And yeah, Aiden, is there anything you'd like to say?
No, as you were saying, if there's any more questions or anybody watches this, just feel free to email us, and I think that's it.
Okay. Thank you for listening.
All right.
Thank you very much. And if there's any question, they're going to send it to your email address. Thank you guys for your time.
Absolutely. Thank you for having us.
Thank you for having me.
Thank you for your time.
All right.
Cheers.
Goodbye.
Yeah.
Bye.
So come to the end of this presentation. So I'm going to meet you guys. We're going to meet up by we'll meet up by 3 for our last class, which is the engineering class. So until then, stay safe and let's have fun. Thank you. Bye.